Hello, welcome to OMEGAMON for JVM, monitoring zOS Connect Enterprise Edition and correlating its APIs with CICS transactions. Today I will introduce a very important feature of IBM's OMEGAMON for JVM zOS Connect, the Enterprise Edition, EE, for API monitoring. I hope this video will help you understand that OMEGAMON for JVM makes API monitoring possible not only for the zOS Connect Enterprise Edition part, but also for the System of Record part, such as CICS and IMS, to identify problematic APIs and its problematic parts quickly. This demo will also show how the combination of OMEGAMON for CICS and OMEGAMON for JVM can correlate API requests with CICS transactions, and how a more detailed problem identification for APIs is possible with a combination of both tools. Here is the environment for the demo. A zOS Connect Enterprise Edition server is running on zOS, and a CICS program runs on a back-end CICS system. The client calls the program with the API name catalog_v.10. The bottom half shows OMEGAMON for JVM zOS Connect Enterprise Edition API provider summary screen. Each tab, numbered from 1 to 6, shows API information, where 1 is by each API name, 2 is by service, 3 is by SOAR ID, that is by the backend subsystem ID, 4 is by reference, which is the backend connection reference defined in the zOS Connect, 5 is resource, which is the transaction or program of the backend system, and 6 is in-flight request. Now let's take a look at the actual screen. This is the zOS Connect API Provider Summary workspace of the OMEGAMON for JVM. The API Name tab displays a summary of the provider APIs issued in the 5-minute period currently set for the API name and HTTP method. In this environment, only the API named catalog_v.10 is being executed by the GET method. In this workspace, you can check the number of APIs issued within a set period of time, average and minimum, maximum response times, and their breakdown, number of error APIs, and number of APIs that timed out. In addition, the Resource tab provides a summary of information by resource type, such as by CICS provider, CICS transaction ID and program, IMS service provider, or IMS transaction code. The rightmost tab, In-Flight, provides details on processes that have been started in the system but not yet completed. The In-Flight tab will be discussed in more detail later. Note that every detail of the API request that runs in the zOS Connect Enterprise Edition is recorded in a zOS log stream using an OMEGAMON supplied interceptor to give valuable and detailed information to the users via this E3270 UI workspace or TEP, the Tivoli Enterprise Portal of OMEGAMON for JVM. This information allows you to see not only the elapsed time of the entire zOS Connect process, but also the elapsed time of the zOS Connect portion, System of Record, SOAR, applications and programs, or even third-party authentication and external APIs where you use an API requester configuration, providing important clues for problem identification. Let's look further at the API Name tab. The Catalog API requests that invokes CICS transaction are sent to zOS Connect Enterprise Edition, and their average response time for 26 requests over 5 minutes is around 10 seconds, with a red warning. As a breakdown, the zOS Connect time average is less than 1 second, while the SOAR time average in the third column from the right is 10 seconds, indicating that there is something wrong with the back-end CICS side. However, there is no indication of the error nor the timeout for these APIs, which means that there seems to be other reasons for this bad response time. Now let us look at the detailed list of the individual CICS catalog API requests in question. In addition to the elapsed time and its breakdown, we can see the transaction name CSMI invoked in the backend CICS and the name of the program DFH 0xCMN being executed. DFH 0xCMN is a CICS sample application accessing VSAM. From the workspace, it seems that all requests show similar response trends. Let's check one of the API requests in more detail. The HTTP code is 200. OK, indicating that the response of this API is normal, and we can confirm that the CICS transaction CSMI and the program that was executed was DFH0xCMN again. If you have OMEGAMON for CICS V550 or higher, you can see the detailed data of the CICS transaction called from this API in the same E3270 UI workspace in the CICS transaction detail subpanel. Based on the correlator passed by zOS Connect Enterprise Edition to CICS during the API call, OMEGAMON CICS identifies the LPAR, CICS job name, and the CICS transaction information being called by this API and displays it in this E3270 UI workspace. From here, we can further investigate the cause of poor response time associated with the CICS SOAR application by clicking the link highlighted in white in this E3270 UI. This link invokes the OMEGAMON CICS workspace for further analysis. Looking at the Timings tab in the OMEGAMON CICS, the interval control wait field on the right side is almost 10 seconds, or most of the API elapsed time. In this case, the slowdown was not caused by external factors, but may have been due to our own wait control within CICS for testing. Using OMEGAMON CICS, we can also check other information such as the performance of the transaction and the data source being accessed. In this way, by effectively combining OMEGAMON for JVM and OMEGAMON for CICS, it is possible to not only visualize the entire API, but also to dig deeper into problems on the SOAR side to help solve them. Finally, let's return to the first zOS Connect API provider summary screen in OMEGAMON for JVM and review the in-flight tab. Workspaces in this E3270 UI show all APIs that are in flight, the phase of processing they are currently in, and the amount of time they have spent running so far. Now we can see one API which is currently in flight. The phase of processing is shown as pre-SOAR, SOAR, or post-SOAR in this workspace, and we can do further investigation into the cause of poor response time. In this example, SOAR is set, indicating that API has called the CICS service, but the response for CICS has not yet been returned for the zOS Connect side. If pre-SOAR is set here, it means that the zOS Connect Enterprise Edition has accepted the request but has not yet invoked the SOAR application. And if post-SOAR is set here, it means the zOS Connect has accepted a response from the SOAR but has not returned a response to the client. This in-flight tab allows the user to see at a glance where the in-flight request is actually stuck and to move forward with problem identification. Today, I introduced an overview of an important feature of the OMEGAMON for JVM, zOS Connect Enterprise Edition API Monitoring, and how we can get useful information by correlating zOS Connect Enterprise Edition APIs with CICS transactions using OMEGAMON for JVM and OMEGAMON for CICS. Please let me add that OMEGAMON for JVM provides support both API provider configuration and API requester configuration. For further information, contact your IBM sales representative or visit the link shown here.